So the last thing I'd like to touch on before finishing off this series is how GraphQL fits into a microservice architecture or in organizations that have multiple teams building a specific product or suite of products. This website here, principledgraphql.com, goes into 10 different principles around building not only a GraphQL API, but really a GraphQL organization. Part of the benefit of GraphQL is having a single entry point to all the data for a particular product. But for complicated products or organizations, this work may need to be distributed among several different teams. The organization behind Apollo GraphQL put together this website to help organizations think through this process of providing a single unified GraphQL endpoint that could be comprised of APIs across a multitude of different teams. So we see here under the one graph principle, Apollo recommends your company to have one unified graph instead of multiple graphs created by each team. They discuss some of the benefits of this, such as data and services being accessed by a single query, essential catalog of all available data, reduction in implementation cost, and overall central management of the graph. But in order to do this requires treating GraphQL as a sort of API gateway, like we discussed earlier in the series. Gateways in general do have a cost associated with them. After all, you are adding now an intermediate layer, which means an extra round trip of requests need to be made in order to fulfill those requests. But there are some advantages to this as well that could offset this drawback. To what degree a single graph is appropriate probably depends more on the organization and how related its different products are. But for the sake of this discussion, we'll assume that a single graph across the organization is appropriate, and this known trade-off of extra requests is a worthwhile trade-off for the benefits that a single graph provides. So there are really two different approaches to building a unified single graph out of multiple GraphQL APIs. Apollo advocates for a federated implementation, and really they're the ones that have sort of pioneered this approach. But there are other simpler options, particularly schema stitching, that can also achieve this single graph goal in a simpler but less sophisticated manner. So here's what the creators of Apollo say about a federated implementation. Though there is only one graph, the implementation of that graph should be federated across multiple teams. Monolithic architectures are difficult to scale without highly specialized infrastructure, and data graphs are no exceptions. Instead of implementing an organization's entire data graph layer in a single code base, responsibility for defining and implementing the graph should be divided across multiple teams. So basically the goal of a federated implementation is not to just create one single GraphQL API for your entire organization, but instead split that out across multiple teams and then combine those into a federated implementation. Continues on, each team should be responsible for maintaining the portion of the schema that exposes their data and services while having the flexibility to develop independently and operate on their own release cycle. So really this is similar to how you build a service-oriented architecture. The only difference really being that instead of, say, REST or RPC or protobuf or some other API protocol, each microservice has its own GraphQL API. But then these independent GraphQL APIs can be joined into a single GraphQL gateway, if you will. We'll also see that they recommend tracking the schema in a registry. And I kind of touched on this earlier, and I didn't realize that this guideline existed when I recorded that, but it's basically saying the same thing I already mentioned. Basically, this guideline recommends building and maintaining your entire schema as a static GraphQL file in a repository that not only engineers can collaborate on, but business and product stakeholders as well. So we'll see here that it says, just like it's important to track source code in a version control system, it's important to track the definition of your graph in a schema registry. There should be a single schema registry for your company that is the authoritative definition of the graph, rather than relying on whatever processes are running at the moment or whatever code is checked in on a developer's laptop. Like a source control system, the schema registry should store the history of changes to the graph and who made them, and it should understand the concept of multiple versions of the graph in a way that parallels the software development process. So basically what that says is you should have really one repo for defining the end goal of your singular unified graph, and that probably will include not only engineers, but business stakeholders as well. And then the actual implementation of that graph is distributed across a handful of different teams with their own repos exploring their own GraphQL API. And the intent is that this schema registry serves as the contract between the business and the teams building and maintaining those services according to this spec. Now, I'm not going to go into the details of building a federated GraphQL API in this series. I may do a separate video that actually goes into the details of that. But for now, I just want to glance through the documentation that Apollo put out explaining exactly how this works. So you'll see right here we have a few different subgraphs that they're calling them, which would be most likely built and maintained by individual teams within the organization, or could be just individual microservices that are maintained by a single team. Regardless, the idea here is that we're not just building a single monolithic API, we're breaking out into subcomponents or subgraphs that then get unified into a single GraphQL gateway, just like how an API gateway works. Now, as you go through this documentation, it'll explain really the best way to break up your APIs and basically advocates against a type-based separation where each service or microservice defines its own types. Instead, it recommends a concern-based separation. And that is because these different types can have various relations to each other and extend each other. And that's really how a federated implementation is supposed to work. Now, although this is an approach that's been used now for a while, there is a caveat that comes with federation. And that is that this federation approach is really limited to Apollo GraphQL APIs, which means there's some degree of vendor lock-in involved, not only with Apollo as your GraphQL engine, but also with Node.js as your primary language. Personally, in order for federation to be the go-to solution for creating a singular GraphQL API out of subgraphs, I think this approach needs to extend beyond the Apollo ecosystem. In fact, I have made an effort to explore supporting federation in Absinthe, but quickly discovered some things that I found were perhaps suboptimal and potentially barriers to supporting federation in other languages as well. And so what I would like to see is federation become a part of the actual official GraphQL spec, and therefore, rather than become a vendor-specific feature, it can become an actual solution for GraphQL, regardless of language or engine. Being locked into a specific vendor on a specific language does have its drawbacks, and without support across other languages and engines, I don't see widespread adoption of this federation approach in the GraphQL community. Now, luckily, federation isn't the only option we have as far as combining graphs into a single unified API. We also have schema stitching. Schema stitching is a more simplified approach and is easier to implement across languages and the various GraphQL engines that exist, but does lack some of the advanced features that we get with federation. A couple tools that support stitching include Hasura, which I'm a big fan of. I think Hasura is a great tool for those who are new to GraphQL or already have a Postgres database and want to explore GraphQL with minimal effort. With Hasura, you can simply connect to an existing Postgres database and build a GraphQL schema complete with relations and filtering and searching and all the features you'd like in a mature GraphQL API, and do it pretty much automatically based on your existing database schema. This is a great way to explore GraphQL, but it is also powerful enough and mature enough to be used as your primary GraphQL engine. Hasura supports a variety of advanced features in GraphQL, such as subscriptions, authorization, and even event triggers, which can be used to run business logic or trigger writes to other systems, and is also a very scalable solution, whether you use their cloud service or deploy to your own network. And finally, we have dgraph, which is an actual GraphQL-based database. dgraph could be considered a competitor to Hasura, as it provides a lot of the similar features, as you'll see here. But unlike Hasura, where your actual data is stored in Postgres and therefore relies on joins to build up responses, dgraph is an actual graph database, which gives you a lot of advantages over using a traditional relational database for your graph. And interestingly enough, you'll see that dgraph does support GraphQL federation, but does not support stitching. So with all that said, I'm glad to see these various tools and approaches to building out a unified graph with GraphQL. But it does seem that we're not 100% there yet, and there are a variety of different approaches we can take in building out a single unified graph, but a lot of these approaches can be vendor specific. And so for me to feel completely confident in building out some sort of federated or stitch schema, I would like to see some specification that the GraphQL community can agree upon and work towards before really committing to one specific approach. And although that may take some time before we reach that point, I think the potential and intention behind these approaches are extremely exciting and will eventually lead to an extremely powerful and sophisticated way to build a unified GraphQL API at your organization